So in this video, we're going to be going over Newton's method. So we're just going to get into this. So let's say we want to find a decimal value for square root of 2. Now, we can't find the exact one because it's an irrational number, but we can find an estimate for it, or what it's, equal to, maybe. So, if we have the function f of x equals square root of 2, x squared minus 2, then what is that? Well, the intercepts for this show the square root of 2. So, for this function, it intercepts at positive square root of 2 and negative square root of 2. So, for whatever problem you're trying to solve, just make it into a function and then make it to where the intercepts for that function equal the thing you're trying to find a decimal approximation for. So, how do we start with Newton's method? Well, let's write this graph a little bigger. And let's just say we're going to try to solve the positive. Alright, so this is a rough graph of x squared minus 2, and then it intercepts at square root of 2. So, let's just plug a random number into this function, and it could be a close estimate for square root of 2. So, let's plug in f of 2. So then that would plug out 2. So, that would be like, let's say 2 was right here, along here, and it led to 2. Now, let's find what's the slope of this line over here. Well, let's just find the derivative of the function. Alright, and then the derivative of the function is 2x, and therefore the derivative, or the slope of this function when x equals 2 is 4. So, using some math and whatever else, we can find that if we want to make a line, a linear function, to represent this line here, of the slope of the line at x equals 2, what do? Well, let's think about this critically. So, the slope, of course, is 4. So, it goes down 4, and then it's 2 away. So, what would that be? That would be... Oh, wait, y'all can see it. Okay. So, what would that be? That means starts up here at 2. Well, let's find the output of this at x equals 2. The output at x equals 2. Oh, wait. Okay, yeah. The output is 2. So, along the y-axis, it's 2. So, that'd be 2 minus 2 times 4, which is 8. So, that'd be negative 6. So, the y-intercept for this along this line would be negative 6. Okay, so if we're trying to find the function, and you gotta think critically about this kind of stuff. It's beautiful when you think critically about it and not just do some formulas or whatever, some other junk. It's fun doing it like this. So, the slope is, let's just call this green line a of x, because it's just a modified f of x, kinda. Well, it's a function. So, a of x would be equal to 4x minus 6, because the y-intercept is 6 and then the slope is 4. Alright? So, we understand? Now, let's find the x-intercept for this function, and then that would just be the x-intercept equals 3 and 3 and, 3 over 2. My bad, sorry. So we're just going to rewrite all this a little bit more fancily. Let's just say f of x equals 2x minus 2. X squared minus 2. And then f prime of x is 2x. F of 2 equals 2. Yep, and then f prime of 2 equals 4. Okay, so we got it. It's all good. So, let's just write this up here. So then, yeah, the x-intercept equals that. But let's say we want to find a of x equal to 0, because then that's what then that's when the x-intercept will be whenever a of x, which is the y line, a of x equal to 0. We set that equal to 0, then that would mean x would be equal to 2, or it would be about 3 halves. Now, I hope you kind of picked up, but the square root of x is equal to x. So it's about 3 halves. But anybody could conclude themselves that 3 halves is close to the square root of 2, since the square root of 2 is like 1.414 or whatever else. So we're going to do it again and get, I think the statistics said that each time you use this method, the estimation gets twice as more likely to be the correct answer, or twice as closer to the correct answer, because you can never technically get the correct answer in a decimal form. So let's do this again. Let's plug 3 halves into the function. Then what do we get? We get 9. We get 1/4. Plug in f prime of 3 halves. Sorry. We get f prime of 3 halves. We get 3. And then, think about it like this. I'm going to use another color. Blue. So then, right here, this line kind of comes up. And then we find the slope of here. And then it kind of goes out like that. And then we find the x-intercept for that line. And it gets a little bit closer every single time. Isn't that a beautiful thing? It's cone. A big lump of knobs. Okay, so to find the x-intercept for this line, let's just call this line b of x. Just go in order. B of x equals, well, what's the slope of this line? Because you see, we're finding the slope of x squared minus 2 whenever x equals 3/4. So that would just be 3x. That's slope, 3. And then we also have to find the y-intercept. So that would be 1/4 minus 9 halves, because you take this minus the product of these two, which we've demonstrated that beforehand, so hope you kind of got it ingrained in your head. So, and that's, I'm sorry, I'm bad with arithmetic, it's the whole thing. Alright, and then minus 17/4. That's the function that represents the blue line. So, let's set b of x equal to 0, because then that's where this line will equal 0. So, we find that b of x equals 0, then, add 17/4 to both sides, get this, and then we find that x is about 17/12. So we're getting closer. That's just one more time, and we'll have a pretty close approximation. So let's plug. I'm gonna use another color again. Red. So right here, you see it's getting extremely close. It'll never be exactly square root of 2, but it's getting extremely close. So plug that in. Get this line even closer. So let's do the formula again. So f of 17/12. Hope you can see why we're taking this again. You see the pattern? We could just do this over and over again. Then what do we have? What's the function? Crap, yeah, we plug it in because this is f of x. And then we get 17 squared over 144 minus 2. Okay, so it's getting kind of rambunctious. And then f prime of 17/12, that would be 17/6. And I hate having this number up here like this, so I'm going to just work out what 17 squared is. Okay, yeah, my bad. It's 289. So 289 minus 288, that would be 1/144. So 1 over 144. And so we do the formula again. Let's make another function called c of x. And then we take the slope, 17/6x. And then we find the formula 1/4 minus 289, because product of these. Oh. And 72. And then that becomes 144 1 minus 578. Okay. And then that becomes 1. Okay, we got it. Over 144. And then we know that this becomes 17/6x minus 577 over 144. Alright. Let's just erase all this trivial math. Alright. So, what do we do? So we set c of x equal to 0. And then we add this number to both sides. We have 577 over 144 equals 17 over 6x. So then we multiply both sides by 6 and then divide both sides by 17. So then we get 577 times 6 over 144 times 17 equals x. Now, we're not going to simplify it down because that's something you could just use on a calculator. Is that clear? Okay. Yeah, it is. So, we can reasonably conclude that the square root of 2 is roughly about 577 times 6 over 144 times 17. So, this is just a rough overview, kind of the derivation of Newton's method. Not exactly, because I'm bad at explaining stuff, but we used it for an example. And yeah, hope you like this video. Bye.